evaluation of network operations, understanding streaming network operations, core technologies and architectures, telemetry and data collections methods, key benefits and uses in real-time networks, popular tools and platforms, AML in streaming network automation, case about the real-world implementations, future trends and innovations, live demo and architecture diagram. Okay, first, what is networks automations? So, the network automation is nothing but it is an process of using software to automatically manage, configure, test, manage, configure, test, deploy, and operate network devices and services. So the key points are automated configurations, reduced manual effort, policy-driven operations, closed-loop feedback, integration with DevOps tools, and scalable management. In that, the definition is network automation is the uses of software, scripts, and programmable systems to perform network tasks such as configurations, monitoring, provisioning, and troubleshooting with a minimal human interventions. So automated configuration management is nothing but the devices like routers, switches, and firewalls are configured automatically. Second one is reduced manual effort. The reduced manual effort supposed automatically eliminates repetitive tasks and the risk of types of misconfigurations. So policy driven operations is based on network behavior, is defined by high level business rules or intents. These policies are translated into device level instructions dynamically. Next, closed loop feedback. The closed loop feedback support with self correlations. So real time telemetry enables automations adjustments like rerouting during congestions. The network can detect and re-intimate them its own self-healing process. Next, integration with DevOps tools. Integration with DevOps tools work along tools like Git, Jenkins, and RESTful APIs. Support version of control testings and automations pipelines similar to software development and Windows. Last one is scalable management. The scalable management spreads along with can manage thousands of devices across data centers or cloud platforms consistency and quickly. So critical for large scale or hybrid infrastructures. Next, evaluation of network operations. From traditional to streaming based models, there are 5 based models belongs with network operations. First one, manual configurations. Second one, the manual configurations belonged with automation tools. Second one is polling based monitoring. It consists of streaming telemetry. Device follows the centric and service centric methods. Statistic networks follows dynamic intent based networks. Reactive operations having predictive and self-healing networks. The evaluation of network operations. The first one, manual configurations. Before, network engineers had to log on each devices using CLI, but automation tool using Python, Terraform, push configuration to multiple devices simultaneously use predefined templates or script. Second, pooling based monitoring. Before we are used networks were monitoring using SNMP protocols, but in that use device push real-time data consistency using streaming telemetry method for faster responses. Third one, device-centric method. Before operations focused on managing individual devices, switcher, router up follows. Nowadays, end-to-end service performance follows device-centric or service-centric methods. Next, static networks follows dynamic intent-based networks. Before that, we are using network path and policies were named manually defined as fixed. Nowadays, using SDN method, software defined networking methods. Last one, reactive operations. In reactive operation, predictive and self-healing methods using. Before that, teams waited to issue to occur, they investigated and resolved them. But after that, AI and telemetry detect patterns and predict using before they are occurring, triggering automatic renovations. Next, what is streaming network operations? Streaming network operation is the use of real-time continuous data streams for network devices to monitor, analyze, and automate network operation instantly. So, continuous real-time network data collections, enabling automated actions and analytics, push-based versus pull-based monitoring. In that, using push operation, example CPU usage, traffic status like errors or the central systems. Unlike traditional polling, unlike traditional polling, unlike traditional polling, data is at center soon as available with minimum delay. Okay. Next, enabling automating actions and analytics. The operation have to be performed to wait for and polling cycles. Dynamic responses, immediate alerting, automated remediations are followed at enabling automated actions and analytics. Third one, push-based versus pull-based monitoring follows on foundation on automation of AI. This allows
Yes, ma'am. Yeah, for the PowerPoint is not moved, still in the first page.
First screen?
Yeah, still in the first page.
Still in the first page, ma'am.
Yeah.
First screen. Ma'am, now you can disable the PPT.
Yes, ma'am.
Okay. Okay. Next, technologies behind streaming OPS. Key technologies powering real-time network automations. So GRPC, Google Remote Procedure Call, Yang, yet another next generation models, open configuration, network configuration, REST configurations, message brokers, KFK, containerization and microservices like Docker and Kubernetes, AML engineers. So in this, based on technology behind the streaming nations, yeah, first one GRPC, Google Remote Procedure Call follows a high-speed open source communication protocol used to send telemetry data from device to collectors. Second one, Yang, yet another next generation tool. The data modeling languages used to define structured data for network devices. Open configuration based on the collaborative initiative led by network operators to define open standardized young models. Net configuration based on a protocol used for retrieving and modifying devices configuration using XML over SSH. REST configuration is a lightweight process. It is based on HTTP version that uses JSON. Both work in young models to explore device data and configurations. KFK, the Apache Kafka, is a distributed event streaming platform used to handle high volume telemetry data. Other brokers like MQTT and RabbitMQ can also be used for message queuing. It is a backbone of telemetry data pipelines. Role of telemetry. Role of telemetry data. So it is telemetry network. Telemetry is the backbone of streaming network operations. First, what is meant by telemetry? Telemetry networking refers to the automatic transmission of performance, configuration, and state data for network devices to a centralized system in a real time. It contains model driven telemetry, push down streaming, granular and configurable, support real time analytics, replaces legacy SNMP polling, secure and scalable. So telemetry using traditional method like SNMP, which uses periodic pooling. Telemetry uses a push based model, allowing data to stream in lifetime. So model driven telemetry, MDT, based on young model, what data should be collected. It is structured, consistent, and vendor neutral. Push down streaming, based on devices pushed down automatically to collect it and changes. Third one, granular and configurable. Operator can choose what metrics to monitor: CPU, bandwidth, link states, etc. How often to stream, and from which user interface to occurs. Next, enables real-time analysis, based on enable proactive and automated network management tool. Replaces SNMP polling. It focused on near instant updates. Next, architecture of streaming network automation. It consists of sensor and collectors, message bus, processing and analytics layers, feedback loop for automations. First one, in that phase, connect device layers. So the device layers, it contains network devices act as a sensors. The generated and pushed telemetry data such as interface states, CPU load, latency, and errors. Often used ANG plus gRPC open configuration for unstructured vendor natural data export. Next one is a collection layer, based on it mainly based on gather telemetry from multiple devices and prepare it for processing. Third one is a transport layer. The transport layer mainly focuses on deliver high speed telemetry to analytic tools with low latency. Processing layer extract insight and triggers decision from raw data streams. Automation and actions layer behind with reconfigure devices, reroute traffic, restart services, launch workflows. The function is automate responses to network conditions or policy violations. Data collections method. So the data collections method, in this it is a various methods used to gather network data, which serve as a foundry of telemetry, monitoring, and automations. So different collection methods suits different use cases, such as legacy, which other support real system, structured and scalable automations. The first one, model driven telemetry, focuses on devices stream structured high frequency data using ANG model. So the ANG model follows us on model methods, which network devices push structured data. Uses protocol, data is sent continuously instead of being pulled periodically. Second one, flow-based monitoring. In the flow-based monitoring, collects flow-level traffic data from routers and switches, shows who is taking to whom, and how long, how much it was exchanged by the network flow, IP fix, understanding bandwidth usage and detecting anomalies like DDoS. Detection of services attacks using the flow-based monitoring. Packet capture integration follows capture entire network packets for in-depth inspections. So in that capture raw packet on the wire for deep inspection and troubleshooting. Tools like Wireshark or DCTP dump are commonly used. Provide complete visibility, but it resources is intensive. Key benefits. So key benefits are reduced mean time to repair, better scalability and visibility, proactive user issue resolution, intelligent and automations. Reduced MTTR is nothing but instead of hours or days, problems can be addressed in seconds or minutes. Less downtime, improved user experience, or higher operational efficiency. Next, proactive problem management follows on better scalability and visibility. Before continuous monitoring helps identify issues before they become critical. Use cases. Real world applications of use cases are congestion detection and dynamic routing, real world DDoS mitigations, anomaly detections, QA's adjustment based on usage. Tools and platforms. So tools and platforms, Cisco DNAC, Juniper Constrail, Prometheus plus Grafana, Open Telemetry, ELK Stacks, Ansible, Stack Scans, Terrafana. In that, telemetry collections and transport, a lightweight high-speed communication protocol for streaming telemetry data. Next, monitoring visualization, open source dashboard for visualizing matrices and alerts in real time. Third one, automation and orchestrations follows automates tasks like provisioning, configuration, and remediations. Fourth one, network controllers follows on centralized network states and telemetry platform with real-time analytics. Next, integration with AIML. Integration with AIML based on predictive analytics, anomaly detection, automated root case analysis, intelligent traffic optimization, self-healing networks, intent-based networking. What is AIML and networks operations? AIML and networks analyze the massive volume of a real-time telemetry data that network generate instead of waiting for human to interpret patterns, machine detect problems, predictive future events, and response automatically. Anomaly detections models, the ML models learn what normal traffic and behavior look like. Any deviation is flagged instantly in predictive anomaly detections. In that phase, it analyzes the historical telemetry for forecast trends like bandwidth growth or devices, can predict failures. It enables proactive maintenance or better resource planning. Next, root cause analysis. It is nothing but if the network issue occurs, it forms a new root cause analysis. AI scans across telemetry sources to automatically identify the source. Saves hours of manual investigations. It reduces MTTR dramatically and improves response precisions. Next, self-healing networks, intent-based self-healing networks based on AI decisions, automation tools. If a path becomes congested, traffic is rerouted automatically. Intent-based networking and IBM based on uses AI to translate high-level business goals into network configurations, monitor the network continuously to ensure that is intent is always meet and correct. If not, challenges and risk. While streaming network automation brings speed, intelligence, and efficiency, it also comes with a real world challenges and potential risk for the organization must plan and mitigate. First one is data overload. Streaming telemetry generates huge volumes of real-time data, especially in large networks. Without proper filtering or aggregation, system can be overwhelmed. Next, security constraints. Continuous data flows increases exposure to data leaks, spoofing, or tampering. Attackers could intercept or manipulate telemetry streams or automate attacks via APIs. Next, skill gaps. AI telemetry protocol automation tools, it requires specialized skills. Traditional network engineers may not be trained in the technologies. Next, integration complexity. Integrating telemetry with the existing monitoring tools, automation platforms, and legacy system is non-triable. So, it consistent data format and API can create fictions. Um, Next, vendor lock-ons. So some platforms offer powerful features but are proprietary. Moving away can be closely or technically difficult if the solution is too tightly integrated. Lack of flexibility, higher long-term cost. Case study. Real world implementations. In real world implementation, organization uses tier 1 telecom operator, region, North America, objective reduce network downtime and improve SLA compliance using streaming telemetry and automations. So in that phase, we have to use um, organization methods, real-time analysis, patch Kafka, Grafana, that can be used to provide triggering actions, isolate faulty hardware. So outcomes are, so in the future trends using self-healing networks, intent-based networking, network digital twins, cloud-native network automations, AI-driven predictive analytics, zero-touch automation at scale, convergence of IT and network operations. Effective keywords: streaming telemetry, real-time monitoring, model-driven telemetry, intent-based networking, network orchestrations, ops, data pipeline, network observability, closed-loop automation, zero-touch configuration, open configuration, NIT configuration, REST configuration, dynamic provisioning, gRPC. So in that network automations, the process of automating configurations, management, testing, and operation of network devices. Streaming telemetry follows on continuous push-based monitoring of network data in real time. Real-time operations based on immediate processing and responses to network events without delay. Closed-loop automations based on automated feedback loop where actions are triggered and adjusted based on live network data. So gRPC, a high performance open source streaming protocol often used with telemetry. Young model data modeling languages used for device configuration and telemetry schemas. So in that phase, streaming network actions on work. So streaming network operations and actions include a visual workflow or architecture diagram. Telemetry sensors, Kafka, stream process, automation engines, and dashboards. Optionally, include a short GIF or video demo link. So call to an actions is focused on step to initiate audit your existing network capabilities, identify telemetry capable devices, select a streaming data pipelines, choosing automation tools, train your team on model driven telemetry and scripting. So workflow using mainly focus on based on stream process outputs, Ansible playbooks or script are triggered. Example of network automations: restart a services, reroute traffic, apply new configuration, notify admin via email. So getting started with the network automations, audit your existing network capabilities, review current devices, monitoring tools and configurations. Check if existing infrastructure supports model driven telemetry. Document performance and visibility gap. Identify telemetry and gapable device. Focus on look for routers, switches, firewalls that support streaming telemetry protocols. It focuses on platforms compatible with open configurations. So select a streaming data pipeline. Choose a message bus or streaming tool, Apache Kafka, InfluxDB, Prometheus, MQ2T, gRPC collectors from smaller environment. Choose automation tools. The automation tools start with well supported, widely adapted tools like Ansible for network automations and device configurations, Terraform for infrastructure provisioning, Salt Stack and Netmiko or Python script for more customizations. Okay, next, train your team on model driven telemetry and scripting based on model driven telemetry concept, streaming data architectures. It mainly focuses on automation script, YAML, Python, CLI, and open configuration of young usage. So types of network on automations. So types of network automations based on device level automation, service level automations, policy level automations, workflow automations. So device level automation, CLI scripts, SNMP, net configurations. So device level automations, CLI scripts, SNMP, net configurations involves automation of tasks directly on network devices. Common tools, Bash, Python script, Ansible models. Task automated, interface configurations, IP assignment, routing protocol setups. The automating interface up and down state with applying ACLs ACLs across hundreds of routers. Service level automations based on automate services that spans across multiple devices. Ensure consistency in applying end-to-end configurations. Typically involve provisioning virtual network functions or traffic policies. Next, policy level automation is based on intent-based networking, used business interns or service level policies automatically configure and enforce network behavior. So it mainly relies on AML to continuously monitoring, validate, and optimize performance and security. So also known as intent-based networking protocol. So workflow automations, end-to-end orchestration with Ansible, Terraform, etc. Focusing on automating multi-step process across different systems, provisioning, testing, verification, and reporting. Often part of CAE, CD, pipelining for network changes, easy consistency, rollback, capability, and auditability. Use case automating device provisioning, pushing configurations, running validation tests, updating dashboards, all in one triggered workflow. Next, components of a streaming telemetry systems. The components of sensors, collector, message bus, stream processor, visualization, and automation layer. Sensor, it based on routers, switches, and firewalls. Function, they are the telemetry data procedures. Sensors are embedded in network devices and collect real-time metrics such as CPU usage, traffic volume, error rates, BGP states, and more. Next, role, continuously export data using streaming protocols like GNMI, gRPC, or open configurations. Replaces the old rule-based SNMP pooling with a push-based model. Next, collector, a server or services that receives telemetry streams from devices. Often includes basic data validation, normalization, and buffering. It prefers data for processing by parsing and storing it temporarily. Example, telegraph, open telemetry collector, custom built GNMI receivers. Next, message bus, a high throughput pipeline that transport telemetry data between components. Tools like Apache Kafka, MQTT, RabbitMQ handle real-time stream distributions. It role supports scaling, partitioning, and replaying data. Stream process is mainly focused on process and analysis incoming telemetry in real time. Task includes filtering noises using detecting anomalies. Real-time event handling, the event triggered by interface down, high CPU usages, BGF flaps, packet drops. Automated responses focus on generate alert, reroute traffic, trigger script, update dashboard instantly. It stores streaming network automation systems a response to critical events immediately as they occur without waiting for manual input or periodic polling. It showcases the core power of real-time telemetry, not just observing but reacting in milliseconds. Events that can trigger responses. Events that can trigger responses. These are the examples of common high-impact events detected in the modern network. So interface down. A router or switch port goes offline, causing potential connectivity issues. High CPU usage based on device processing overload can affect performance or service availability. BGP flags based on routing instability, where BGP connections frequently go up and down, risking packets loss or delays. Packet drops. Packet drops lost due to congestions, faulty hardware or misconfiguration affecting applicants QoS. QoS, automated responses trigger in real times. Once the event, that automation system reacts immediately and intelligently, often without human interventions. So generate alert. It's an instant notification via email, Slack, or ticketing systems. Reroute traffic, automatically shift data flows away from the impact path using SDN or dynamic routing. Triggers script, run predefined script to reset interfaces, adjust QoS, or modify configuration via Ansible or CLI automations. So update a dashboard instantly. Visible dashboards like Grafana and Kibana reflect the incident in real time, aiding situational awareness. These responses from the basis of closed loop automations, where the system continuously monitors, detects, and reacts with the minimum human delay. Next, zero touch provisioning. So definition: automatically configure a new network devices, when connected without manual input. How it works: device boots, fetch configure script from server, join network with correct policies. So role of API in automations. Northbound APIs used for dashboard integrations, orchestrations, example with web UIs or OS systems. Southbound APIs interact with the devices via REST configuration. Why APIs matters? Enable programmability and modularity across platforms. So netbound APIs based on used for integrating network automation platforms with higher level applications. So orchestration systems, business support systems, operation support systems, custom with dashboard or portals. Next, southbound API is focused on used by automation platforms to interact directly with the network devices, reading or writing configuration, collecting telemetry, or executing commands. So network configuration or REST configuration for model-driven configuration. CLI over SSH, GNMI or SNMP for device level data collections. It provided by vendors. Why API matters in network automations: interoperability, programmability, modularity, speed and scale, observability and control. So interoperability based on API allows tools from different vendors to work together. Programmability based on enable writing custom script and apps to automate repetitive tasks. Modularity based on API allows system to be loosely coupled, easy to replace or upgrade individual components. Speed and scale: AI-driven network scale faster and reduce the manual effort drastically. So observability and control: expose matrices, logs, um, held health data in real time for telemetry driven decisions. Streaming versus traditional monitoring as a comparison of features. Traditional streaming telemetry: data delivery is pull based and streaming telemetry is push based. Frequency is low in SNMP, in streaming technology is high. Format is structured, another one is it is structured in SNMP, structured young in streaming technology. Overhead on devices: medium in SNMP, low in streaming telemetry. Real-time responses is limited in traditional and fully streaming technology. So works on push model. Streaming technology use a push model to continuously for collecting the streaming data. Industry adoptions examples. So in industry adoptions examples, Google, AT&T, Cisco, Netflix. In Google implements intent-based networking to manage its massive global networks, uses machine learning to predict faults and trigger self-healing mechanisms in their wide area network. So Q uses using next AT&T. So using streaming telemetry and closed loop automations, it is a software defined network infrastructure. Network even triggered automated decisions for routing, scaling, or alerts. Cisco, it is a DNA center, DNAC platform uses streaming telemetry to gain real-time insight into device and network health. Support AI-driven policy enforcement and proactive troubleshooting. Netflix implements real-time observability for its global and infrastructure, continuously monitors app edges, and networks performance to ensure seamless streaming. So matrices to monitoring in streaming. So matrices in monitoring streaming, CPU memory usages, interface errors, traffic drops, BGP OSPF states, application latency, device temperature, flow count or bandwidth per port. So this is mainly for key performance matrices that should be continuously monitored in a streaming network operations environment. These matrices are pushed in real time from network devices, allowing a rapid detections, analysis, and responses. Why this matrices matters? High availability, low latency, quick troubleshooting, effectiveness, automation decisions. Common matrices are CPU memory usages, interface errors, traffic drops, BGP OSPF states, application latency, device temperature, flow count, or bandwidth per port. In that, CPU memory usages detect hardware stress, performance bottlenecks, or potential failures. Interface errors is based on includes CRC errors, collisions, input or output drops, useful for identifying faulty ports or cables. Traffic drops may focus on packet loss due to congestions or misrouting can lead to poor application performance. BGP OSPF states monitoring dynamic routing protocol to ensure proper path convergence and stability. Application latency. So in application latency, end-to-end delay affecting user experience. So device temperature mainly focuses on prevents overheating related shutdowns or failures, especially in high density environment. Flow count, bandwidth per port helps to detect overutilizations, DOIs patterns, or sudden traffic spikes. So carrier roles in network automations. So network automation engineers, uh, DevNet, DevSecond Ops engineer, um, apps specialist, works on ML predictive spare playlist, telemetry architect, so Python, YAML, Ansible network configurations. DevNet devs engineers based on Mesh network plus security and automations. AI specialist follows on works on ML for predictive network analytics. Telemetry architect designs streaming data pipelines and observability tools. So network automation engineer follows Python, YAML, Ansible, and network configurations. Write scripts and playbooks to automate devices configurations and automations. Devices and service automation scripting tool integrations. Second, DevNet DevSecOps engineer follows on mesh networks plus security and automation in automated pipelines. It secure infrastructure as a code deployment and manage API driven networks. So AI specialist follows on ML, AI models, data science, log telemetry analysis. Telemetry architect focused on how it is based on the another networks. So it is not followed by the telemetry architects. So should not used for the design framing a data pipelines and the observability tool. So matrices and monitoring matrices and monitoring CPOS follows on the CPA memory usage. The CPA memory usage detect hardware stress, performance bottlenecks, or potential failures. Interface errors follows on include CRC errors, collisions, input and output drops, useful for identifying false ports or cables. Traffic drops focus on packet logs due to congestion or misrouting can lead to poor application performance. BGP or OSPF states monitoring dynamic routing protocol to ensure proper path convergence and scalability. So application latency mainly focus on end-to-end delay affecting user experience. The device temperature is mainly focused on preventing overheating related shutdowns or failures, especially in high density environment. So flow count bandwidth with port. It helps detect over-utilization, DOS patterns, or sudden traffic spikes. In streaming versus traditional and monitoring a comparison of traditional in SNMP, simple network management protocol works a full model. When monitoring tools periodically request data from devices, streaming telemetry, it works on a push model where device continuously stream data to collectors. In SNMP, pulls every 1 to 15 minutes, making it hard to detect fast network changes. But streaming telemetry sends update as frequently as milliseconds, offering real-time visibility. In SNMP, data is often unstructured or loosely structured, making it harder to parse, normalize, or correlate across devices. Streaming telemetry uses young data models for consistency and vendor neutral format. SNMP. In SNMP, based on repetitive polling, can strain CPU and memory, especially on large or older devices. Streaming technology, efficient encoding, and asynchronization push result in minimum device resource usage. Industry adoption example: implement intent-based networking to manage massive global networks using a machine learning to predict fault and trigger self-healing mechanism for wireless area network. Zero touch provisioning. In the zero touch provisioning based on automatically a new network configuration connected with the manual input. So in the manual input, device boots. The device boots when a new device is powered on, it automatically start up with STP process. So fetches configure script from server. It reaches out to provisioning server to download a configuration script or image. Join network with the correct policies. So applies configure and join networks. The download script includes interface configuration, host name, routing setup, policy enforcement. The device that automatically becomes operational, adhering to company policies. So components of streaming telemetry systems is sensors, collectors, message bus, stream processor, visualizations. In that, automated response triggered in general alert is send instant notification via email, stack, or ticketing systems. Reroute traffic, automatically shift data away from the impacted path. So triggered script mainly focus on run predefined script to reset interface, adjust QoS, and modify configuration via Ansible or CAL automations. Update dashboards instantly. So the update dashboards focus on visible dashboards like Grafana or Kibana reflect the incident in real time, aiding situational awareness for the systems. So zero touch provisioning mainly focus on configured automatically with the components of a streaming telemetry system. So call to actions for the elementary systems. Audit your existing network capabilities, identify network telemetry capable devices, select a streaming data pipeline, choose automation tools, train your team on model driven elementary scripting. Before that, effective keywords in ADOPS pipelines and network observability. The network observability focus on packet starts due to congestions, faulty hardware, or misconfiguration affecting application beyond the OS, beyond the network operating systems. So interface down means a router or switches port goes offline, causing potential connectivity issues. High CPU usage, device processing overload can affect performance or service availability. Routing instability where PGP connections frequently go up and down for the packet loss. Thank you.
Yeah, we have some question, ma'am, from
Yes,
participants. Hello?
yes, ma'am.
Yeah, we have some question from participant already read in the Zoom chat.
Yes, network engineers use manual configurations for an uh, network, the streamlining network operation, risk reducing, fault tolerance, or redundancy. It's redundantly reserved for general alerts such as instant notifications via the email or ticketing systems, automatically shift data flow away from the impact path. As example, dynamic routings, run a predefined script to REST interface, QoS, modify configurations via Ansible and CLI automations. The automation tool improved, yes, the automation tool improved our networks as interface configurations, host name, routing step setup, policy enforcements are the automation tool to improve the network operations without compromising control visibility and security. The future network engineer need as a manual configuration is replaced by automated policy-based network management. Yes, the policy-based network management is focused on uh, architecture systems, business support systems, operational systems support, custom dashboard or portals. This can be used to this can be applied through the AP application uh, protocols in application interface protocols. The application interface protocols spin with the VANs or firewalls automatically. Any other questions, ma'am? Yes. To what extent should network administrator rely on AI-driven network management system? On what is oversight still essential? So, the SNMP and streaming technologies option push model and a pull model where devices automatically stream data to collectors for every 5 to 15 minutes, updates as frequently as milliseconds, offering real-time visibility. What are the biggest risk when streamlining complex network infrastructure and how organizations mitigate them effectively? It mainly based on intent-based networking to manage massive global networks, uses machine learning to provide wide area network for organization mitigate from infrastructure network infrastructure.
Yeah, thank you for answering. I guess no one else asking again, ma'am.
Thank you.
Yeah, okay. Before I close this event, for our participant, please open your camera. I will take a picture on the count of three. Okay, one, two, three. Okay, another one. One, two, three. Thank you for your cooperation. Finally, we come to the end of visiting lecture today. We would like to thank you for Miss Dr. Sangeetha for the wonderful information and sharing your knowledge. We hope this information will be beneficial for our participants. At least we hope to have more collaboration in the future. The visiting lecture for today and here. We hope to see you soon. Thank you and have a nice day. Thank you so much, ma'am.
Thank you.
Yeah.